Good morning student. I Kinnari Dave welcomes you all for Standard 11 Unit 4 Chemical Bonding and Molecular Structure Part 4. Student, in the previous part we have studied about the covalent bond and the factors affecting and what is the properties of that covalent bond. Now we are going to study what are the exactly parameters to find the covalent bond or what is the characteristics of the covalent bond. Previous video I have already explained you about the bond length also and bond angle also. So they too are also considered as a parameter for the covalent bond. So now today's session we are going to study the all four parameters of the covalent bond. So just student, look at the board. Now the bond parameters are, the first is bond length, then bond angle, which we have already studied in the previous video, but then also here we are continuing with the same topic in the form of difference of. So the clarity of this thought will be very much clear in your mind, because this is the very important terms which you are already studied in the unit 3 also, but then also we'll continue with the topic which we have ended with the last videos. So bond angle, then third parameter is bond enthalpy, and the fourth parameter is bond order. As student, last video we conclude that bond length you can understand that length means what? The distance, and generally distance is measured in meter, centimeter, but here we are talking about the atom. Atom is a spherical and very small particle, indivisible particle. So here meter, centimeter is not a unit, but we are measuring the bond length in picometer and Armstrong. So now just come to the definition of the bond length. Bond length is considered as an average, or we can say equilibrium distance. Distance of what? Student, here we are talking about the molecules. So when two atoms are tightly bound with one another and they forms the molecule, so the radii of the one atom and the radii of the another atom, when they becomes the molecule, the total distance of the both the atoms radii, that is the considered as a bond length. So that's why it is known as the average distance or a equilibrium distance. So the average distance between nuclei of two atoms in a molecule. Two atoms are combined and forms the molecule. So both the nuclei, here I have drawn also in our last video also I explained you. This is atom A and this is atom B. When they combine and forms the molecule, suppose AB, then the radii of this, it is R1, and the radii of B atom is, I have written as a R2. So what is the bond length? Bond length is R1 plus R2, that is known as the bond length. So R1 by R2 is considered as a bond length. Here, as I said, it is expressed in either Armstrong or picometer. So 1 Armstrong is equal to 10 raised to minus 10 meter, student. I have written here, that also you have already studied in the unit 3, but if everything we will memorize together by the time, so it is easy to remember that conversion, because in all the numericals some or other way these values are very much important. So 1 Armstrong is equal to 10 raised to minus 10 meter, while 1 picometer is equal to 10 raised to minus 12 meter. So this is the unit for bond length. Now student, which are the factors which affect to the bond length? As you know, suppose the size of the atom molecule which made that two atoms are very small, or somewhere it is possible that I have shown here A is of smaller size and B is of bigger size. Suppose we'll take the example of HCl. So H is having smaller size while the Cl is with the bigger size. So that is also keeping in our mind, that also is the factors which affect the bond length. Other than this, there is some bond order which we have studied in the previous video also. As you know, hydrogen is having only requirement of the one electron. So hydrogen is shared with only one electron and hydrogen forms the single bond. The same way Cl chlorine molecule, Cl2 molecule also is required of the one electron. So Cl is also sharing the one electron and forms the Cl single bond Cl. So that is also affect on the bond length. So now we'll just come to the point, which are the factors which affect to the bond length. First of all, as I have written over here, size of the atom. Size of the atom, as I said, the Cl is very big size as compared to hydrogen. So if we'll think about the Cl2 molecule and H2 molecule, then the atom is more, the size of the atom is more, the length is more, but natural. हाइड्रोजन की साइज एटम की साइज उतनी है तो उसकी जो बॉन्ड लेंथ होगी वो छोटी होगी. क्लोरीन की साइज जो है वो बड़ी है तो क्लोरीन की जो बॉन्ड लेंथ होगी वो बिगर होगी. सो इट इज वेरी क्लियर थॉट स्टूडेंट. द साइज इज स्मॉलर, बॉन्ड लेंथ इज लेस or small. The size of the atom is bigger, the bond length is bigger or more. Here example also I have written as Hi, then HBr, the same way HCl, then HF. So hydrogen and fluorine, suppose we will take the example of hydrogen and fluorine. Mostly both is of the same size and the size is smaller. Hydrogen size and fluorine size is smaller. While if we think about the Hi, then size of the hydrogen is smaller, but iodine comes in the down the group of 17 group element. As you know, fluorine, then second chlorine in third period, then bromine in fourth period, iodine is in the fifth period. So नीचे नीचे जाता है. As will come down in the group in the periodic table, the size of the atom is increasing. So fluorine, then chlorine is little more bigger, chlorine is little more bigger than fluorine, bromine is little more bigger than chlorine, and if we'll think about the iodine, then it is bigger than bromine. So if we'll think about Hi, then size of the hydrogen is smaller while the size of the iodine is bigger. So HF molecule, both the size is smaller because hydrogen is in the center of the periodic table, and if we'll think about the fluorine, then fluorine comes in the 17 group, that is in the second period. So 1s2, 2s2, 2p6, that you are writing here for the fluorine. So that's why here the size of the HF, size of the HF is smaller than the size of the Hi. So Hi की साइज सबसे बड़ी होती है क्योंकि साइज बड़ी है. So size also matters. Now this is very clear to you students. Now the next parameters, next factor which affect to the bond length, that is a bond multiplicity. Multiplicity in the sense, as you know, the carbon is having the catenation property, or we can say that the oxygen also shows the double bond also, the same way oxygen shows the single bond also. So here the double bond, single bond, triple bond, that also affect the bond length. Means bond length is decrease as bond order increase. So this bond order is very important parameter for these all the factors which are the parameters of the covalent bond. This point we can understand by the bond length, as the single bond, then double bond, then triple bond. So bond length of single bond is bigger than the double bond and then the triple bond. Suppose if we think about the example of ozone, so O3 लास्ट टाइम भी हमने यही एग्जाम्पल लिया था. सो इसका जब हम रेजोनेंस के बारे में बात करेंगे, सो we'll get an idea clear about that. ये रेजोनेंस means the either the 6 electron of each of the oxygen is having. Now each of the oxygen is having 6 electron. So if I draw 1, 2, 3, 4, 5 and 6. Now here this 1, 2, 3, 4, 5 and 6, and same way here 1, 2, 3, 4, 5 and 6. So student, here there is a possibility of maybe double bond forms on this side, right hand side of the 2 oxygen, and somewhere the possibility of to draw the double bond on left hand side of the oxygen also. So here as the double bond is the shifted towards both the side, the bond angle, if we'll talk about the bond angle, then the bond angle is exactly the smaller for the double bond and then the single bond. That we will study in the resonance, student. But just you keep in your mind, bond multiplicity is affected. So as the bond length decrease, bond order increase. So bond order जो यहाँ पर है कि यहाँ bond order आपका था 1, यहाँ bond order हुआ 2, यहाँ bond order हुआ 3. So 1, 2, 3. So bond length हो गई आपकी decrease. So this is also the parameter for this bond length. Suppose we'll think carbon is having mostly 154 picometer. Then if double bond, then maybe 130 something picometer. Mostly 133 picometer. And the same way, if we'll think about the carbon triple bond carbon, then it may be the more less than the carbon double bond carbon. So you can understand this. The bond length is also depend on the multiplicity. Single bond is with the maximum bond length. Then the third factor which affects on it, that is a hybridization, student. As I said, the carbon possesses the catenation property, and in the hydrocarbon, the hybridization means the Sp hybridization, Sp2 hybridization and Sp3 hybridization. This is also the next topic of our this video. But here, what is the S character, that I am going to explain you in that next topic as we'll complete these parameters. So more is the S character, greater is the bond length. Sp3 is having more S character than the Sp2. So the bond length is Sp3 की सबसे highest होती है, then Sp2 and then Sp. So these are the three factors which affect the bond length. Now the second parameter for our covalent bond is bond angle. As I had explained you in that previous video also, bond angle means what? The angle between these two atoms orbitals line, that is known as the bond angle. Suppose if we'll think about the H2O molecule, suppose, so here it is oxygen with hydrogen. So here you have two lone pair of electron. So this is known as the bond angle. I have given some example also. Here the example of NH3 is given. Ammonia, I have given the example to you, students. So NH3 bond angle is expressed in the degree, minute and second, students. So bond angle is the angle between orbitals or lines. The lines which we are representing in the form of either Lewis dot structure or in the form of lines. So suppose if you want to express this NH3, then you can express in this way also. NH this way. H2O if we want to express, then we can express H this way. So this is the line considering. In either we are showing this by the Lewis dot structure or by the dot line. So here this is angle between orbitals line represent bond electron pair. Bonded electron pair जिसके बीच में हम line से उसको represent करते हैं, तो उसके बीच का angle that is known as the bond angle. And as I said, it is expressed, the unit is degree, minutes and second. So the angle between this NH3, so two hydrogen, the angle between the two hydrogen, that is 107 degree, which I have written over here. The same way, one more example I have drawn for the CH4. Now angle between this 2H is 109 degree and 28 minutes. Same way I have drawn the H2O also, student. So the angle between this 2H is 104 degree and 28 minutes, or it can be considered as a 4 minutes. 104 degree and 4 minutes. Actually, student, if we will think about this bond angle, then it may be 107, but it is less than 107 because of these two lone pair are. So there is a repulsion between these two lone pair. So they lone pair just try to attack to this bonded pair. So two lone pair of electron oxygen is having, and they both will repel each other. So this electron will come closer to this bonded pair and this electron come closer to this bonded pair, and that's why in place of 107 degree the bond angle of H2O is 104 degree and 4 minutes. The same thing will be here for the NH3 also, students. NH3 is also having the one lone pair of electron. So this both the electron will be repelled to each other and forms this bond smaller than the real it is. So that is the bond angle, student. Now the third parameter, that is the bond enthalpy. In the last video also we have studied what is the bond enthalpy. Whenever the covalent bond forms, or whenever the molecule forms from the cation to from anion, the energy which released, or from the one atom's molecules from one element atom and from the another element atom, when they club to each other, then the energy which release from that own molecule, that is known as the bond enthalpy, and then that is turns into the gaseous form, student. So the definition of bond enthalpy is amount of energy to break 1 mole of bond to separate into the gaseous atom. That is the bond energy or bond enthalpy. Dissociate करना है आपको, करना क्या है, you have to break the bond which is club. At that time when the molecules are, atoms are combined, the energy is, now you have to break that, you have to dissociate that bond. So bond energy required to break that particular bond and to separate it into the gaseous form, that is known as the bond dissociation enthalpy or a bond energy or bond enthalpy also. Simply you just keep in your mind to break the bond when the 1 mole of bond, how much bond is to be break, student? 1 mole, because as we know we are talking about the Avogadro number or a mole per atom. So that's why here 1 mole of energy required to 1 mole of atom to be break, and it should be convert into the gaseous form. So bond dissociation enthalpy unit is kilojoule per mole, because 1 mole and the energy is released, that is a kilojoule. Now the last parameter for this, it is a bond order. As we have studied this also in the last video, bond order as number of bond between the atoms in a molecule. How many elements, atoms are combined, and how many number of electrons they shared for formation of the bond, that is known as the bond order. So here I have given the example, HH is having the single bond because only 1 electron is shared. Same way oxygen is with the double bond because the oxygen has shared the 2 electron. So bond order for oxygen we can say as a 2. Same way if you will think about the nitrogen. Nitrogen is with the 5 valence electron. So nitrogen shares 3 number of electron to complete its octet. So here this is a triple bond. So bond order is considered as a 3 for nitrogen. But student, as last time we have studied some of the exception in the octet rule. Here I have given one example for NO, nitrous oxide. So here you can see the student, nitrogen is with the 5 number of valence electron which I have shown by putting dots, and oxygen is with the 6 number of electron which I have shown to you by keeping the cross marks. So now here the bond between N and O is by sharing only 2 electron. Now if you will see the octet, then this 3, 4, 5, 6, 7. Now this is the incomplete. So 4, 5, 6, 7 and 8. This way the octet will be finished. Same way 4, 5, 6, 7 and 8. Here also the octet will be in such a manner. So bond order is, ये 2 तो clearly आपको दिखाई दे रहा है, N double bond O. So 2 तो clear है, but you can see student here, this is 1 non-bonded electron which is with the oxygen non-bonded electron. So this is half. ये 2 और ऊपर जो है वो है हाफ. Same way for the oxygen also you can see these 2 electron are shared with the nitrogen 2 electron, and this 2 electron means this one lone pair of electron also comes with this. So that's why here for NO the bond order is 2.5. ये बहुत ही important है, ये exceptional है student. So that's why I have given this example to you. Now we'll just go with the next topic, and that next topic is about the resonance and hybridization, students. So now just look at the board. We'll just continue with the hybridization, student. Hope so these all the 4 topics which I had explained you, that will be clear to you. Now we'll go with the next topic, that is so students, now we'll try to understand about the hybridization, student. Hybridization means what? The mixing of an orbital in which the molecule formation atom took part. So hybridization means mixing of atoms orbital of same atom with different energies. Now here this we have to keep in our mind. The molecule, whichever the atoms are combined and forms the molecule, only that atom's orbital can overlap or then can combine with each other, but the energy difference is of both the orbitals are different. Here some of the parameters are also there for the combining or for the mixing of the orbitals. Like that, the first parameter is the atom or ion must be same, as I have given in the definition also. So same atom or ions orbital which is having nearly the equal amount of energies, or we can say the energy difference is there but not a much large energy difference. Means suppose one orbital is with having the 133 kilojoule per mole and another is having the 533 kilojoule per mole. So not that much energy difference, nearly equal energy difference. Means suppose 133 kilojoule per mole example we have taken. So another one orbital may be having nearby 140 or 142 kilojoule per mole. So that is the main parameters. Same atoms or ions orbital have approximate equal or nearby equal energy difference. The second parameter for the same is the number of hybrid orbital. How many number of orbitals are present, they were overlapped, and the total amount of hybrid orbital are also same. Means suppose only 2 orbitals are overlapped with each other, or suppose only 2 orbital mix with one another, then the total is 1 plus 1 is equal to 2. So that is the meaning of that. Number of hybrid orbital is equal to number of atomic orbitals mix. One atom, one orbital, another atom, suppose 2 orbital. So total 1 plus 2. So number of hybrid orbital are the 3 which mixed. So atomic orbital is 3. The next parameter is, it is not compulsory to all the orbitals must be half filled only, or it is completely filled only. Here the main parameter is energy difference is only required. So half filled can also take part, less than half filled also can take part, and completely filled can also be take part. But whenever the that orbital is completely filled, it must be having some another subcell, as a p orbital is completely filled, but it is having the d orbital in the vacant formation. So that can also form the hybridization. So here all half filled or completely filled orbitals with different energy can take part only at the time of the bond formation. Here it is very important point, students. Only hybridization can occur when the bond formation is there. After formation of the bond, hybridization is not possible. So here also you have to keep in your mind with energy difference, either it is half filled or a full filled orbital. But if it is a full filled orbital, then it must have the next orbital is vacant position. The next point is we can get an idea from this hybridization shape and geometry of the molecule. As we know the shape, then we can get an idea about the angle, means geometry of the molecule. And the last point for this hybridization is, if the lobe is big, we can show it by the positive sign. Here I have shown you this. This is a smaller lobe and this is the bigger lobe. So bigger lobe is shown by the positive sign. So these are the main parameters for the hybridization, student. Now hybridizations are of the three types. As mostly the carbon is show all the three hybridization, Sp hybridization also, Sp2 hybridization also, and Sp3 hybridization also, due to its catenation property. So for the example, if you want to write the example for single bond, you can write the example for Sp3 hybridization with carbon is with the single bond. For Sp2 hybridization, you can write the example with ethene, means we can say that for alkane it is Sp3, for alkene it is Sp2, and for alkyne it is Sp3. So this you keep in your mind for the example also. Now just we understand what is the S character, as in the previous topic of this video we have studied about the bond length is depends on the S character also for the hybridization also, and that time I explained you, I just informed you that is our next topic which I am going to explain you what is the S character. So now what is S character? Here hybridization are of three types, as I said, Sp, Sp2 and Sp3. Sp in the sense what, student? One atom's orbital of 1s or 2s and another atom's orbital of 2p. They all will mix, means from 2s and 2px, 2py and 2pz. From this all the 3p, only one px will be overlap or will be mixed. So that is known as the Sp hybridization. Just look at the board, student. I have drawn here. This is our 2s orbital. As you know, the s orbital is with the sphere shape and p orbital is with the dumbbell shape. So 2s orbital when mixed with the 2px, px I have shown you with the dumbbell shape. Student, keep in your mind, here the 1s will not take part because as you know only the 1s energy level is possible. 2p energy level start from the quantum number 2. So 2s plus 2px. Now this is the hybridization which I have shown. This is the px and जो स्फीयर शेप का S है वो आपको मैंने यहाँ पर इस तरह से दिखाया है. So this is the diagonal shape and you can see this is the linear shape and the linear is the angle 180 degree. So this is also known as diagonal. Now we'll come to that S character. What is the S character, students? Here total number of orbitals are how much? 2. 1s and 1p. Total number of orbitals took part 2. So you for the finding the percentage, as you know, you have to multiply it by 2. So S character and P character. So here this is S is of 50% and P is of 50%. Means 1 by 2. You can just divide it by the 2 as I am showing you here. That way it is a 2 part only, so 50% each S and P consist of. But then also by mathematical terms I am just showing you here, so you will get a clear idea now what is S character. So student, S and P, so S plus P is equal to total number of orbitals 2. So for S, divide by 1 by 2, and the same way for P also divide by 1 by 2. Now we have to find the percentage. So percentage is always on the 100. So we'll multiply it by 100, and for the P orbital also we'll multiply it by 100. So here 50% of S character and 50% of P. So here it is same because only the 2 orbitals are there. So here S character is equal. Now we'll go with some of the example of Sp hybridization. As I said, wherever the alkyne means C triple bond C are there, it is having the Sp hybridization. In our next video, student, we are going to study about to draw the hybridization and to understand how to draw the structure for the hybridization, because it is very important topic. So the next video don't miss, student, to watch. Now here example I have given for the Sp hybridization. As I said, alkyne means C triple bond C. One more example I have given, BeF2 and BeH2. These are the example for Sp hybridization. Here even I have shown the unhybridized 2p orbital and 2s orbital. 2p orbital, 2pz is remaining. It does not have the electron. It is a incomplete. It is not a half filled also. It is less than half filled. So now when it mix with one another, what happens, student? This at the excited state, not on the ground state. Hybridization occurs only at the excited state. So this electron just move towards this 2p orbital, and 2pz, which is not filled, that will be filled, and here you can see the Sp bond formation or Sp hybridization is occurs. Now we'll go with the next hybridization, that is Sp2 hybridization. Now in Sp2 hybridization, 1s, here you can see the s is only 1 and 2p. So total number of orbital are 3. So how will you find the s character for this? So now here you can write s plus p is equal to 3. So s is equal to 1 by 3. Same way p is equal to 2 by 3. Because 2p are there. Students, here you cannot write 1 by 3 for s also and 1 by 3 for p also. So here the 2 by 3. Now as usual, multiplying by 100. So here multiply by 100. P also multiply by 100. So here you will get the 33% of s character and 67% of P. So now we'll think about the S character between Sp and Sp2. So Sp is having the 50%, it is a maximum, and Sp3 is having Sp2 is having the 33%. तो इन दोनों की कंपैरिजन में अगर S कैरेक्टर की बात करते हैं, so Sp is having more S character or greater S character than Sp2. Now here the shape or geometry of that molecule is trigonal because it is a 120 degree. 120 degree means it is a trigonal shape, and I have shown you here how this hybridization takes place. The same way here it is 2s plus now here the 2p orbital are there. So we have taken the 2px also and 2py also. So now you can see 3p orbital, you can see px and 2py. With this I have shown this with the s orbital, and the angle between this is 120 degree, and that's why the shape is trigonal. That's why the shape is trigonal. Now the example also I have given here, BF3, BCl3, BH3. These are the example of Sp2 hybridization, student. Now the last hybridization is Sp3 hybridization. Now in the Sp3 hybridization, you get an idea how to identify or how to count the S character, students. So you just tell me what is the answer for the S character of Sp3 hybridization, and meanwhile I'll just try to draw the hybridization of Sp3 with CH4. Student, try to find out the answer for S character of Sp3 hybridization. Very good, student. What is the answer? As Sp3 means total number of hybrid orbital are 1s and 3p. So total is equal to 4. So here 1s means you have to take 1 by 4, and here that is a 3p, or directly you can just say this is a for one part of the out of 4, so 25%, and this is 3 part out of 4, so this is of 75%. So Sp3 is having the least character of S than the Sp and Sp2. Now student, here you can see the shape also. Here I have drawn the CH4, and now bond angle for this is, this bond angle is 109 degree and 28 minutes. And the shape you can see, this shape is known as the tetrahedral shape. Same way we can draw for the water molecule also. H2O is also having the same way tetrahedral shape. That also I am just showing you. This is our next video's topic. But here just I give you the idea how to draw and how it affects to the geometry. So now H2O is also having the Sp3 hybridization, oxygen and hydrogen. As oxygen is having the 6 valence electron, only 2 took part for the formation of that. So here this is the lone pair of electron, and this lone pair of electron also possess the as a sigma bond. That's why it is also having the tetrahedral shape. But that shape is will continue with the next video. Here we'll just conclude with only this for the hybridization. So I hope so student, this topic which we have studied in this today's video, the 2 topics we have covered. The first one we have studied the bond parameter, and the second topic we have studied about the hybridization. Hybridization is very important even for the organic part of the chemistry also. So clear this point by watching the video again and again, students. And yes, you have to not forget to subscribe my channel. Thank you so much, student. Thank you.